Hello students, in today's class we'll study numerical solution of one-dimensional wave equation. So as I said before, in this class I'm going to derive an explicit formula for wave equation. So that consider one-dimensional wave equation. So one-dimensional wave equation we have to consider. It is given by dou square u by dou t square is equal to c square into dou square u by dou x square. We call this as equation 1. Now with the conditions. So this equation subject to the boundary conditions, subject to the boundary conditions. So what are the boundary conditions given? U of 0 comma t is 0, u of L comma t is also 0, and initial conditions are also given, that initial conditions are u of x comma 0 equal to f of x and ut is equal to dou u by dou t of x comma 0 is equal to 0. So this is the one-dimensional wave equation given with the initial and boundary conditions. For equation 1, we use the finite difference approximations. As we studied in the last class, we use those finite approximations. So finite difference approximations, this is dou square u by dou t square and dou square u by dou x square. Again, the function in two variables x and t. The standard formula what we have studied, that is for two variables x and y we have considered. So in place of y we have t here. That is the only difference. Ali y iddalli ಇಲ್ಲಿ t ಇದೆ ಅಷ್ಟೇ. ಸೊ ಲಾಸ್ಟ್ ಟೈಮ್ ಕಲ್ತಂತಹ ಏನು ಫೈನಲ್ ಡಿಫರೆನ್ಸ್ ಫಾರ್ಮುಲಾಸ್ ನಾವೆಲ್ಲ ನೋಡಿದ್ವಿ, ಅಲ್ಲಿ y ಇರುವಂಥ ಫಾರ್ಮುಲಾಸ್ದಲ್ಲೆಲ್ಲ ಟಿ ಹಾಕಬೇಕು ಅಷ್ಟೇ, ಬೇರೆ ಏನೂ ಡಿಫ್ರೆನ್ಸ್ ಇಲ್ಲ. ಸೊ ಫಾರ್ ದೋ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೋ ಟಿ ಸ್ಕ್ವೇರ್ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಫೈನಲ್ ಡಿಫರೆನ್ಸ್ ಫಾರ್ಮುಲಾಗೆ ಏನು ಫಾರ್ಮುಲಾ ಬರ್ತಿದ್ರಿ ಅಲ್ಲಿ ಅದನ್ನೇ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಬೇಕು ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ ಡೋ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೋ ಟಿ ಸ್ಕ್ವೇರ್. ಸೊ ಬೈ finite difference approximations, by finite difference approximations, in 1 by k square into dou square u by dou t square, it is u of I comma j plus 1 minus 2 times I comma j plus u comma u of I comma j minus 1. This is for j. So this is equal to c square. The same way for x, it was 1 by h square into u of I plus 1 comma j minus 2 times I comma j plus u of I minus 1 comma j. This is the equation. So now we make some necessary arrangements, that take that 1 by k square to the RHS. When you move that to RHS, then equation becomes in LHS part u of I comma j plus 1 minus 2 times u of I comma j plus u of I comma j minus 1, and here it is c square. When you take that k square to RHS, so it is c square into k square h square. Write on the remaining terms as it is. U of I plus 1 comma j minus 2 times u of ij plus u of I minus 1 comma j. Now we'll put k by h. Let k by h as lambda. So this implies k square by h square as lambda square. So what happens? So ui j plus 1 minus 2 times ui comma j plus ui j minus 1 equal to c square lambda square, these terms as it is. It's ui minus 1 comma j. So now keep ui j plus 1 here and move all the terms to remaining terms to the chest. ui j plus 1 ಇಲ್ಲೇ ಇಟ್ಕೊಂಡು ರಿಮೈನಿಂಗ್ ಎರಡು ಟರ್ಮನ್ನು ಈ ಕಡೆ ತಗೊಂಡು ಹೋಗ್ಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಯು ಐ ಪ್ಲಸ್ 1 ಜೆ ಆಸ್ ಇಟ್ ಈಸ್, ಇಲ್ಲಿ ಯು ಐ ಜೆ ಇದೆ, ಇಲ್ಲಿಂದ ಒಂದು ಯು ಐ ಜೆ ಬರುತ್ತೆ, ಎರಡು ಸೇರಿ ಬರೀತೀವಿ. ಸೊ ಸಿ ಸ್ಕ್ವೇರ್ ಲ್ಯಾಂಬ್ಡಾ ಸ್ಕ್ವೇರ್ minus 2 times c square lambda square uij, ಇದು ಈ ಕಡೆ ಬರುತ್ತೆ ಪ್ಲಸ್ 2 times ui comma j, ಎರಡನ್ನು ಸೇರಿ ಪ್ಲಸ್ 2 times uij 2 into 1 minus ಇಲ್ಲಿ c square lambda square in common uij plus c square lambda square ಏನು ಉಳಿತು ui plus 1 comma j plus ui minus 1 comma j, ಇವೆರಡು ಟರ್ಮ್ ಹಾಗೆ ಉಳಿದು minus this term u I comma j minus 1. Now to find explicit formula, let us choose to find explicit formula. Let's choose 1 minus this one c square lambda square. We choose it as 0. So when you choose this as 0, what happens? 1 minus, already you know c lambda square is what? K square by h square equal to 0. What it indicates? C square k by h whole square is equal to 1. Yes. Or you may say k is equal to k square is equal to h square by c square, k is equal to h by c. So 1 k equal to h by c. And by using this, you can say c square lambda square itself is equal to 1. Anyone you can use c square lambda square equal to 1 and k equal to h by c. So we use these notations in this equation. So it is u I comma j plus 1 equal to u I minus 1 comma j plus u I plus 1 comma j. ಹೇಗೆ ಬರೆದೆ? In place of c square lambda square ಇಲ್ಲಿ ನಾನು 1 ವ್ಯಾಲ್ಯೂ ಹಾಕಿದ್ದೀನಿ. ಸೊ 1 ಹಾಕಿದರೆ ಇದೆ ಹಾಗೆ ಉಳಿಯುತ್ತೆ ಯು ಐ ಪ್ಲಸ್ 1 ಕಾಮ ಜೆ ಯು ಐ ಮೈನಸ್ 1 ಕಾಮ ಜೆ. ನೆಕ್ಸ್ಟ್ 1 minus c square lambda square ಇದೇನಿದೆ? It is 0. So that's why this whole term becomes 0. Next ಏನು ಉಳಿತು? Only we left out with u minus u of I comma j minus 1. So ಇದು ಏನು ನಮ್ಮದು explicit formula. ಇದು explicit formula. ಇದನ್ನು ನಾವು equation 2 ಅಂತ. So this is known as explicit formula. So ಇದನ್ನು ನಾವು explicit formula ಅಂತ ಕರೀತಾರೆ. derivation. Next ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ you are given with the boundary conditions and initial conditions. So we have to use them. Now by using the initial conditions, by using the initial conditions, now the ut equal to dou u by dou t x comma 0 equal to 0 ಈ ಕಂಡೀಷನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಈ ಕಂಡೀಷನ್ ಯೂಸ್ ಮಾಡಿ ಯು ಟಿ ಅಂದರೆ ಯು ಐ ಏನು ಬರೀತಿದ್ರಲ್ಲ ಅದು. ಸೊ ಯು ಟಿ ಏನಾಗುತ್ತೆ 1/2k u of I comma j plus 1 minus u of I comma j minus 1. Then ಇದೇನೀಗ with t equal to 0 ಇದೇನಾಗುತ್ತೆ when t is equal to 0 t ಅಂದರೆ y ಅಂದರೆ ಏನು ಜೆ ಕೆ ತಗೋತಿದ್ವಿ. ಸೊ ಜೆ ಕೆ ಏನಾಗುತ್ತೆ ಜೆ ಕೆ 0 ಆಗುತ್ತೆ. ದಿಸ್ ಇಂಪ್ಲೈಸ್ ಜೆ 0. ಸೊ ದೇರ್ಫೋರ್ ಇದೇನಿರುತ್ತೆ ಡೋ ಯು ಬೈ ಡೋ ಟಿ ಇದು ಟಿ 0 ಇದ್ದಾಗ ಇದು ನಮಗೆ 0 ಇರುತ್ತೆ. ಸೊ ಇದು 0 ಇದ್ದಾಗ 0 ಇರುತ್ತೆ ಅಂದರೆ this part dou u by dou t ut is nothing but dou u by dou t. So therefore in this equation this part LHS becomes 0. So 1/2k equal to into u I comma j plus 1 minus u I comma j minus 1. What it implies? This means u of I comma j plus 1 minus u of I comma j minus 1 equal to 0, or you can say u of I comma j plus 1 is equal to u of I comma j minus 1. With what we are considering initial condition j equal to 0. So that implies u of I comma 1 equal to u of I comma minus. So by using the initial condition, what we have u of I comma 1 is equal to u of I comma minus 1. So explicit formula, therefore explicit formula 2 is explicit formula, that is equation 2 becomes j equal to 0. So now that equation 2 what we have considered at j equal to 0, that equation becomes u I comma ಏನಿತ್ತದು ನಮ್ಮದು explicit formula ಇದು ನಮ್ದು explicit formula. ಇಲ್ಲಿ j 0 ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ? So when you put j as 0, I comma 0 plus 1 equal to u of I minus 1 comma 0 plus u of I plus 1 comma 0 minus u of I comma 0 minus 1. That is u I comma 1 is equal to u of I minus 1 comma 0 plus u of I plus 1 comma 0 minus u of I comma minus 1. But just now we have found that is u of I comma 1 and u of I comma minus 1 both are same. So this is equal to u of I comma 1. Therefore take this to LHS. So 2 times u of I comma 1 equal to u of I minus 1 comma 0 plus u of I plus 1 comma 0. What it implies? u of I comma 1 is equal to 1 by 2 u of I minus 1 comma 0 plus u of I plus 1 comma 0. Call this as equation 3. This is equation 3 by using the initial condition. Now, by boundary condition, boundary condition, what are those? U of 0 comma t is equal to u of 0 comma t ಅಂದರೆ x ವ್ಯಾಲ್ಯೂ 0 h t ಅಂದರೆ jk y ಟರ್ಮ್ ಅಂತ. ಸೊ 0 h jk ಏನಾಗುತ್ತೆ ಯು ಆಫ್ ನೊಟೇಷನ್ 0 to j 0 comma j ಇದೇನಿದೆ 0 ಇದೆ. And also u of l comma t u of l ಅಂದರೆ x ವೇರಿಯಂಟ್ ಸೊ ಎಲ್ ಎಚ್ ಇದು ಜೆ ಕೆ ಸೊ ಯು ಆಫ್ ಎಲ್ ಕಾಮ ಜೆ ಅದು 0 ಇದೆ. ಸೊ ವಾಟ್ ಇಟ್ ಇಂಡಿಕೇಟ್ಸ್ 0 to j ಎಲ್ ಟು ಜೆ ಅಂದ್ರೆ ಏನು? ದೀಸ್ ಟು ಮೀನ್ಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ that is the values along first and last column they becomes 0. First and last column in a mesh. Whatever values we are going to find, we tabulate them in table. So that is called as a mesh or 0. That is 0. That is my boundary. Now we use the another boundary condition, sorry, initial condition, that is by initial conditions, it is u of x comma 0 is equal to x ಅಂದರೆ ಐ ಹೆಚ್ಚು 0 ಇಂಟು ಜೆ ಏನಿದಾಗುತ್ತೆ ಇದೇನಾಗುತ್ತೆ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಐ ಅಂತ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಐ ಮೀನ್ಸ್ ವಾಟ್ ಎಫ್ ಆಫ್ ಐ ಎಚ್ ಅಂದ್ರೇನು? using this condition you are going to find the values along first row. ಅಂದ್ರೆ first row elements ಏನು ಬರ್ತಾವ ಅಂದ್ರೆ when you are go on putting I as 0 1 2 3 4 you will be getting x0 x1 x2 x3 x4 like this. So using this we can find first row elements in the mesh where by using initial condition so u by dou t at t equal to 0 it is all 0 we have seen. And lastly we can find we have found first column and last column elements are 0 by using the given initial conditions, and then boundary conditions. Then by initial conditions we conclude the row elements by using the given equations, using the substituting the values in the given equation, differential equation, and then the remaining finds values of the mesh we can find second row elements using u I comma 1 equal to 1 by 2 u I minus 1 comma 0 plus u I plus 1 comma 0. Previous ಆಗಿ ಫಾರ್ಮುಲಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಲ್ಲ ಅದರಲ್ಲಿ using the condition, that is equation 3. Using equation 3, you are going to find the second elements. Next, first column, last column, first row and second. Then remaining whatever rows left in the mesh, we can solve them, find those values by using the explicit formula what we are already that explicit formula, that is equation 2. This, using this equation you are going to find the remaining elements. So next, to find remaining elements in the mesh, we have to use explicit formula, that is equation. So this is the explicit derivation for the wave equation. So in the next class I'm going to solve some examples of wave equation. Thank you.